All right, so let's go ahead and see how you did. The equation is y equals x minus 4 squared plus 1. So the first question says the graph of f of x has a minimum value. Well, let's go back and review. This parabola has a positive a value. So because your a value is positive, your parabola is positive, so your graph opens upward. So we would say there's an imaginary 1 there, okay, and that's what makes it open upward. So for number 1, we would say the graph of f of x has a minimum point. Because it's positive and it opens upward, the graph does have a minimum, so we would say that is true. All right, number 2, the graph of f of x has a vertex at 4, -1. Well, y equals x minus 4 squared plus 1 is the original equation. We take the opposite, comma, same in order to get the vertex. So our vertex is at the opposite of a -4 is a +4, and 1 stays the same. So our vertex is at +4, +1, and this says -1, and it's supposed to be a +1, so therefore we're going to say this is false. All right, number 3, the axis of symmetry is at x equals 4. Well, if you have the vertex, you have the axis of symmetry. Since the vertex is simplified here, your x value is 4, and that represents your axis of symmetry for short. So if this says x equals 4, then it is true. So hopefully you got that correct. The axis of symmetry, again, is what cuts the parabola into 2 equal parts. All right, so the y-intercept is at 1. Now, if you recall, in standard form, the constant is what gives you the y-intercept. I think it was practice number 6. So in standard form, ax squared plus bx plus c, the c is the y-intercept. So what they're trying to do here is, in the original equation, the y-intercept is at 1. They're trying to trick you and make you think that this is your y-intercept. The reason this is not the y-intercept is because this equation is in vertex form. It is not in standard form. So this is not the y-intercept. If it was in standard form, then it would be C. So to get the y-intercept, we let x equal 0 and plug it into the original equation. So for example, we're going to let x equal 0. So it's going to be 0 minus 4 squared plus 1. In order to solve for the y-intercept, we let x equal 0. So we let x equal 0. So we're going to get y equals a -4 squared plus 1. Now remember PEMDAS, we always simplify exponents first. So if there's no parentheses. So -4 times a -4 is a +16 plus 1. So the y-intercept is actually 17. So when x is 0, y is 17, and this is your y-intercept. So it's at 17, and they said it's at 1, which is false. All right, and number 5. Again, let's remember how to read this. F at 1 is 10. F at 1 is 10. What is that saying? Well, it's saying when x is 1, y is 10. So we have to determine that by seeing when we plug in a 1 for x, do we get 10 for y? Well, let's see if that's true or false. So let's plug in a 1 this time for x. All right, so we're going to plug in a 1 this time for x into the original equation. So it's going to be y equals 1 minus 4 squared plus 1. And we're letting x equal 1. All right, so let x equal 1 and see what y is. All right, so again, we start within the parentheses. Remember PEMDAS. 1 minus 4 is 3. Now we do exponents. So 3 squared, 3 times 3 is what this is saying, is 9 plus 1. So 9 plus 1 is 10. So when x is 1, y is 10. That is true. Cool. So y is 10. So if I go back up to the original warm-up, f of 1 is 10. That is correct. All right. So thank you for taking a few minutes on this warm-up. It just kind of captures what we should have been looking at, some of the concepts from lessons 1 through 7.